All right, guys, this is Unit 1A, okay, Quiz Form D being worked out. So just make sure that this is the form, okay, that you are given on quiz day. Okay, feel free to pause, fast forward the video, replay the video at any point in time. Now, one thing we're going to do in this no calculator section is I'm just going to go ahead and make a list of my perfect squares. Okay, so I can reference those while I'm working. And remember, 2 times 2, 3 times 3, 4 times 4, 5 times 5. And we're just going to keep building up on this list. Okay, and we could continue, but I'm just going to use this as a reference point. Okay, anytime I see something that's like the value of money, I always think about trying to take a quarter out of it because that's a perfect square. All right, so when I start my breakdown, how many quarters go into $1.25? That would be 5 different quarters. All right, as I take the square root of this item, okay, you're going to multiply it out to the front. 4 times 5 is 20, and then you have a rad 5 left underneath. So 20 rad 5 is the final answer. 5 is not divisible by any of the perfect squares, so that's completely simplified what the directions asked for. Okay, coming over here, we have a number and we also have variables. So we got to think to ourselves, what can I divide out of 72? What I'm thinking of is 9 times 8. Okay, then if we have a variable raised to an even exponent, we do not need to break it up because it is a perfect square. Now the one that is an odd exponent, we're going to break it up by pulling one of the variables to the side, leaving you with an even and an odd situation. Okay, and then this one is just z, remember that'd be to the power of 1. So I'm going to go through and I'm going to highlight what is perfect. These are the pieces that I can go ahead and immediately take out. The square root of 9 is 3. The square root of x to the 4th is x to the 2nd. So whenever you're taking the square root of an even exponent, you're just dividing the exponent by 2 when you pull it outside. So then y to the 3rd. 6 divided by 2 is 3. Right, so now I've taken these items out, and what I have left underneath is an 8yz. The last issue is that this 8 is divisible by one of our perfect squares. Okay, so we're going to actually have to go ahead and break that down even further. This was one of the major errors where quite a few of you guys lost points by not completely simplifying. Okay, I'm going to break this down into 4 times 2. Okay, the square root of 4 is 2, so when you bring it out, you have to multiply it out to the front. 3 times 2 is 6. Then I have x squared, y cubed, rad 2yz. That would be my final answer. Coming down to number 3, 64. Oh, that's nice. 64 is actually a perfect square, and the square root of 64 is 8. Once you take the square root of something, it's no longer under the radical. Now the square root of m squared, just like we talked about in number 2, if it's raised to an even exponent, then it is perfect. And when you take the square root of m to the 12th, it's m to the 6th, right? And let's think about the reason why. M to the 6th times m to the 6th, right, times itself, is equal to m to the 12th, right? Just like 8 times 8 is equal to 64. Okay, so the square root of 64 is 8. The square root of m to the 12th is m to the 6th. And if you need a reminder, right, why is that 12? Well, m to the 6th just means you're multiplying m to itself 6 times. 1, 2, 3, 4, 5, 6, right? M times m times m times m times m. Well, then you're multiplying that by m times m times m times m times m times m. If you add all those up, that is 12 m's, okay? That's the reasoning behind the rule of dividing the exponent by 2. All right, coming over here to number 4. In order to add and subtract radicals, they have to be like terms, meaning the number under the radical has to be the same. If the number under the radical is the same, then you can combine the like terms, okay, by adding their coefficients. 6 plus 4, that is 10 rad 5s. Again, you are just adding the coefficients given that they're like terms. I think about addition and subtraction like giving and taking. Okay, if you have 6 rad 5s and I give you 4 more, you now have 10 rad 5s. Okay, coming over here, again, in order to add and subtract radicals, they have to be like terms. Right now, none of these are like terms, but I can simplify the square root of 18. I could break that up into 9 times 2. Remember, when I'm breaking it up, you want to try and divide by a perfect square, right? Divisible by 9. Let's write out the other terms. Okay, some of you guys need to be better with your scratch work, carrying everything down to the next step. Okay, the square root of 9 is 3. Remember, you multiply that outside of the radical. Negative 6 times 3. Now the decision that we have to make is, are any of these like terms? So let's think about it. Rad 2, those are like terms. Okay, so you're just going to add the coefficients or combine the coefficients of like terms. And negative 18, okay, minus 8. Let's think about that. Negative 18 minus 8. That's going to give you a negative 26 rad 2 plus 4 rad 3. All right. Last situation. This sign, right, you're multiplying. And for multiplication, you do outside times outside and inside times inside. 4 times negative 3 is negative 12. 6 times 10 is 60. But here's the issue. A lot of you guys stopped right here. You can simplify this. Okay, 60 is divisible by a few different perfect squares. Maybe you can think about dividing it by 4, or maybe even dividing it by 16. No, that wouldn't work, but 4 would work. We could break it into 4 times 15. So negative 12, 4 times 15. The square root of 4 is 2. You're going to multiply that outside. Negative 24 rad 15. And that concludes, oh no, I'm so sorry. I just caught that I didn't have that underneath the camera. Okay, that concludes the video, okay, on how to complete the first portion of Unit 1A quiz Form D. Thanks for listening.